All right, so yeah, let's make that thing bounce. Let's do 2D bouncing finally, just like we did for, just like we talked about on our last main programming kind of lecture. So let me pull open my notes really quick. Sorry, it's in the wrong spot. So yeah, our goal, right, was to do this thing from the office and have a little bouncing square moving all around our screen. Let's see, I need bigger pens. That one. Let's go back to green. There we go. So what we wanted, right, was we draw our little square for a window, and then we put a littler square inside of the big square, and then give it a random initial direction, and then it starts bouncing off the walls, moving in that initial direction as far as it can, and bouncing, and moving as far as it can in that direction, bouncing off a wall when it hits one, and making that kind of movement that we expect. So yeah, it'll go on until the end of time, and hopefully eventually hits the corner too. So that's where we're going. We talked about that. So do you remember the game plan? So what do we already have? Like, we already have code to draw the screen boundaries. So let's keep that, of course. We have to worry about where they all are. It was a 400 by 400 square, right? Centered at 0, 0. So this is like, this is 0, 0 right in the middle there. This is going to be in the upper left. That is negative 200, positive 200. And then down here in the bottom right would be positive 200 in the x, negative 200 in the y. So you kind of see how that's happening. And then we make a square. We're going to make the turtle a square, put them in a random location within those boundaries. So just like set as x and y somewhere between negative 200 and positive 200 for each coordinate. Same, because it's square, it's inside of. And then, so it's here now, it's random. And then give it a random direction. So we learned how to represent directions inside of our programs now. It's in addition to, like, not just an offset in the up direction, it's an offset in the left and right direction as well. So you'll end up with an arrow, something like this, which is made up of go a little bit to the right maybe, a little bit in the positive x-axis, and a little bit in the positive y-axis for this particular direction. And that is going to correspond to movement eventually. If we say, all right, after a certain chunk of time, the next frame, we're going to move this square to be a little bit more to the right and a little bit more up, and that's going to produce diagonal movement. Okay, that's where we're going with that. And so we'll just shoot off the square in that direction until it hits the wall, and then we'll have to figure out how to bounce it off. And we did talk about that last time too. So just keep bouncing off those walls. So yeah, after we give that initial direction, we hit our forever loop again. It's just like forever. What do we do? Move in that current direction as long as we can, if there's nothing in our way. But eventually we will hit a wall, of course. And when that happens, we want to bounce off of it. All right. So just the movement was the same as before. The movement before walls was the same as for the bouncing ball, up and down. It's just like worry about the x-axis as well. That's all. Okay. So let's see, where were we? We also talked about like how we're going to program this, right? We have those offsets and things like that. The turtle's going to be the square, of course. The direction will be 2 offsets. So we have like, let's see. Turtle's the square. If we choose this direction, let's say we want the square to move in this direction, that has a corresponding set of 2 offsets, one for the x and one for the y. So like there's an x offset and a y offset for each direction that you could possibly have. I'll call it x off and y off. And then like if the turtle exists right here at xy, that's its current coordinate, then after a certain amount of time, we'd like to move him up here. After a frame, the turtle should go here, which is, what is that coordinate? Well, it's the original x plus the x offset, because we're moving in the positive x direction. And then the y, the original y, plus the y offset, because we're moving in the positive y direction as well. But the sign is going to take care of all that. And just like any direction you might ever want to go can be a combination of an x offset and a y offset. Hopefully you remember that. Okay. So this is all coming back to us. We did talk about this last time. Are there any questions about it now that we're seeing it again? Because we will program it today. Okay. That's going to be the goal. So yeah, we're going to have that random direction, and every direction has an associated x, y offset. And then I want to deal with normalizing that offset as well. So I'll have to draw that in just a second. But let's see. How do I want to do this? Yeah, just as easily as you could go up to the left, you can go up to the right. This is going to be a, what is it? A negative x offset and a positive y offset, but it's always just like you're making a little, what's it called? You're making a right triangle. If you want to go the exact opposite direction, that's going to be another right triangle, but what's the x offset? It's positive this time. Go right, and then go down, so a negative y offset. All right, this will make more sense when we code it up. But I think that's what I want to start with, so let's do that. I think that's what I want to do right now. Well, let's get that started. So let's copy and code from last time. Let's see how far we can get before we need to worry about wall bouncing. So let's see. Let's go to my desktop. Let's go to code from class, and here we are. And I think it was this lecture, bounce. Yeah, the one without the gravity. So I'm going to copy this in, and we're going to change it. So let's make a lecture folder for today. Is it lecture 28? Let's see. Yeah, so lecture 28. Oh gosh. I hope I didn't click the wrong button. Lecture 28. Hopefully that thing's still copied. Yeah, cool. So I'm going to change this to 2D bounce, maybe? Let's see, what did I call it before? 2D-bounce.py. So I'm copying in what we used to have, and I'll open this in idle. So if you'd like to follow along, you can go to our code from class page. This is from lecture 26, I think. And so here was just the normal 2D bouncing stuff that we did even before that. It was the just up and down only. Remember that? Let's get that over there. Don't worry about the rest, but here's that one. Now we're going to modify this. All right, so the turtle is not going to be a ball anymore. The turtle is going to be a square, and it needs a random spot. So let's start with all that. This is what we had from before. Like, draw the rectangle. Here's the bounding square. The circle is not going to be a ball this time. It's going to be a square. So let's go to the library documentation page. See how to do that. Dun, dun, dun. So it's a shape. Turtle.shape something function. There we go. So you say turtle.shape, and as a string, you say what kind of shape you want. So sometimes we like it to be a turtle. We had it be a circle before, but now we want a square. All right, so let's make the turtle the square this time. So we'll pass along to the shape call, shape square rather than shape circle. Make the turtle the square. Oops. And so turtle.shape square. And I don't know, we can give him a different color this time. He can be purple, let's say. And then we'll stretch him the same amount. I think that's fine. And that's going to give us same width and height of this square because we're stretching it in the same amount. Each axis will be 40 by 40 units in turtle land. So that's a good start. Let's run that. It just makes a square now rather than a circle, but it's still bouncing up and down, of course. Whee! So we got a purple square now. Going up and down. So, what's the next step? What are we still trying to do here? So, let's give the turtle a random spot within the boundaries as it begins its life. So, not just initially at the very tippy top. Let's give it another spot. So, let's take care of all that. Variables to keep track of where the turtle is. Is that what I said? Where the ball is. I guess we can keep it that. And where it should move. Square, I guess. So this is where we start the turtle. There's like this exact x offset, something random, and then this y offset was not random. Okay? So we do want it to be random, and like let's make it a bit more fancy. Let's have this be between like negative 150 and positive 150. That's still within the bounds of 200 on each side. And we'll do the same for the y. This y was exactly grazing the tippy top of the wall. Let's make it somewhere in the middle now, potentially, randomly. Could be the top of the wall still. So let's do that same thing, okay? So that's the goal for that. And then, what does that look like? So now when I run the program each time, it's going to be a random spot just somewhere within this bounds where the ball starts its life, but it's still starting going down because I'm only doing y offsets. So if I rerun it, the turtle's going to start. Watch where it starts. It's going to be a random spot. So now it was very close to the bottom. You see that? So that's going to be different every time. So that's a good start. And then we want to worry about a random direction as well. All right. So what do we need? Random direction to start, and a direction is a pair of offsets. It is an x offset and a y offset as well. All right. So both of those all at once, and those are going to affect where the turtle moves to. Okay. So let's start coding that up. That's going to be important. Let's see here. Let's make that happen. So instead of turtle offset, because that was just for the y, let's have an x offset and a y offset. Okay. So this is going to be our direction for maybe x. We'll also make one for y offset. Right? X offset is something random, and then y offset is something random. Well, we'll figure this out together. So we'd like some numbers. Like I used to have like 0.5, 2. If I want a random number that is a float, I can't say rand int because that would be a whole number only. So if I would like a random float, turtle Python random, it's called random.uniform. Where is that? Come on. There we go. Random.uniform, you give it two things, and it will give you a floating point number within that range. So let's make the x offset and the y offset some random thing, some random number between. Let me show it to you on the REPL. Import random. Random.uniform. If I say random.uniform like negative 1.0 and positive 1.0, it'll give me a random number between those that's a floating point, so anything in between. Any fractional value. So that's kind of what we want here, because we want to move just a little bit, not like integer chunks. So let's make those our offsets. So every frame will move a little bit, maybe left or right. Random.uniform between negative 1.0, so negative x direction, or the positive x direction. So it could be anything, like go left or go right. And then for y offset, it could be random again, go up or go down. So we'll do the same one, negative 1.0, positive 1.0. So these two together will form our direction. These two variables together will form our direction. Okay? That's going to be how those work. And let's see. So every frame, we would like the turtle's position to be affected by the direction. So just like we did this one, change the turtle's y-coordinate by the offset, we want to change the turtle's entire position, x and y, by both of our offsets now, because we're moving each frame a little bit to the left / right and a little bit up and down. Okay? That'll give us diagonal movement if we change x and y together. So let's do that. I don't want to do this. Let's do this. So I'm going to mess with like x offsets and y offsets. I'm going to change them eventually, so I'll make them global here, just so that I'm able to change them later. Because we're going to mess with a turtle x and turtle y for sure, and then the bouncing off the walls is going to deal with the offsets as well. So we'll mess with that soon. So there's all that, and let's see. Yeah, so change the turtle's x-coordinate and the y-offset, and the y-coordinate by the offset. So turtle y gets changed by the y-offset each frame, and same with the x-coordinate. Does that make sense? We're changing it by however much we said to change it by, all right? Plus the x offset, so it's changing each time. And this was bouncing off the top and the bottom walls, and so it's going to mess with offsets, and this, we have to like rename this. This will end up being the y offset, so we'll deal with that in a second. Then, but let's just pretend it doesn't exist. I don't know where to put all this right now. I don't want to have it run even right now. Is there a way to comment out all of this right now? Format, comment, region. Yeah, cool. Alt 3. So I've just made all of this bouncing stuff comments because I had it was just turtle offset before. I don't want to mess with it right now. We'll deal with all that later. But draw frame, what's it doing now? It's just moving the turtle by the x and the y offset and moving the turtle to that place. So we're not dealing with the wall right now. All right, so we get a random direction, random position initially, and random direction. And that random direction is affecting our x and y each frame. So let's watch this work. So we're moving diagonally now. So the x offset was apparently positive and the y offset was also apparently positive. And we're just vanishing off the screen right now. Isn't that fun already? So we're picking a random direction. That's what we're doing. And so here, apparently this direction is a bit to the right again, but down as well. So the x offset is positive. Hope that makes sense. And then the y offset is going to be negative because it's moving us downward slowly but surely. Any questions about how that works from just these two random variables? Whatever they are, they're giving us movement. All right? Let's see what else. Let me try it one more time. So remember how slow it just moved, by the way. There it goes. Now it's moving to the left and down. So a negative x offset and a negative y offset. And now it's off the screen. So are there any questions about that before I do some fancy stuff to the offsets? Because these random numbers kind of correspond to, right? If I made, remember the other offsets, like if you make the offset huge, it moves it fast every frame because it's moving farther. Same with these. If the x offset, the absolute value of the offsets are large, that means it'll move a bit farther each frame. And so like all these directions, like this is the same direction as this. These two arrows are the same, but if only I can draw the same angle, sorry. But like, let's pretend, like what would this offset have been? This was like 0.25, 0.25. And this would have been 0.5, 0.5. Does that make sense for the x and the y offsets? That's the same direction. We could have gotten either of those randomly, but one's going to move slower than the other. Like this one's slower. Do you see how it's moving a little bit less each frame than this one? It's moving by 0.25 in that direction, in those two directions, rather than 0.5. And that's, again, not the same as 1, 1. That's also possible. Same direction, but the x offset is 1 here. The y offset is 1 here. It would be nice, and that's like a different speed. It would be nice to just always have the same speed regardless of which direction we pick. All right, that's where I'm going with this. So let's normalize it. So let's make it so that no matter which direction we pick, no matter which random direction we pick, let's have it always be length 1, like the hypotenuse of that direction triangle. Have it always be length 1, so it's just like along a circle. It's always length 1 rather than like 0.5 or 0.25, whatever that is. Does that make sense? Because that'll make it move regardless of our direction. It'll make it move at a constant speed every time we rerun the program, right? Because sometimes randomly it would go slowly versus other times randomly it would go fast because we're not doing what's called normalization to our direction. So let's see if I can get it to go slow again. It's like it's going pretty slow, this one, because it's small increments for the x and the y offsets. But randomly, it might choose bigger ones. Whee! That was about the same. Whee, that's a little bit faster, I would say. Definitely the x offset is negative, but it's a large negative number, right? More negative. I hope that makes enough sense. So what we'll do is we'll make sure like this x offset and y offset forms a bit of a triangle in some way. Let's make it so that the length of the hypotenuse of that triangle, that's like the amount we're moving each frame, let's make it so that it's 1, all right? That's what we're going to do. So let me try and make that happen to you. So this, like it's forming a triangle. It has an x offset and a y offset. What is the length of the hypotenuse of that offset triangle? It's, well, this is like a squared and this is b squared, right? Equals c squared. We're going to do Pythagorean theorem to determine that. So we'll need the math library. I guess I don't need time anymore. I was showing you that before, though. So let's normalize that offset. So no matter what, it's going to go in the same amount each time. So let's normalize our direction so that it has a length 1 hypotenuse. All right, so let's figure out the length of that hypotenuse right now. It's going to be, this is like a, this is b. It's going to be the square root of a squared plus b squared. Remember that? So the direction, hypotenuse, length. Let's make some silly named variable for that. That's going to be the x offset squared, a squared, right, plus b squared, it's the y offset squared, it's the other side of the triangle. And it's equal to c squared. We want to solve for c, so we're going to take the square root. Remember this? It's been too long, maybe. So that's going to be the length of our hypotenuse. And if I just divide, the x offset and the y offset by whatever this is, it will make it so that the hypotenuse is 1. Okay? So that's the idea. So turtle x offset, whatever you were. Maybe you were small, maybe you were large. I'm going to normalize you so that you were, u plus your y offset is length 1 now. So that's what we're doing there. And when I rerun this, it should be very obvious that it's going to move at the same speed regardless of the random direction. So now, we did a little math. Now the length of the hypotenuse of this direction triangle is 1. All right? So if I run this now, we're modifying that random x and y offset so that it's always going to move at that speed. So just remember what that speed is on my screen right there. We're making sure that no matter which direction we pick, it's going to move at that exact speed. Whee! So that same speed in that direction this time. It's a length 1. We're moving one turtle unit every frame now in some direction. Cool. Any questions about that? It's a bit of a weird idea, but it makes it a bit more nice, I would say. Because we just wanted the direction. We don't want speed associated with that direction. We want to be able to control our speed. All right. Are we ready to bounce off the wall? Let's do it. So, okay. Here was our bounding coordinates. Now we have to get specific now. Did I? Yeah, I'll do it in a second. I want to draw this as straight as possible. Easier said than done. Alright, so this is what? Negative 200, positive 200. This is our bounding square. And so this is the line x equals negative 200. Yeah? Like this is 0, 0 right in the middle there. So that's our coordinate system. And so we have to make some if statements again to figure out like when did we hit the walls. So when did we hit this left wall, for example? Like when do we know that we're grazing that wall or trying to go outside of it? So now we have to really worry about the size of things, right? Because the turtle, when it's right here, it's not like its x value is exactly negative 200 because its coordinate is relative to its center. Okay, so what's the coordinate of the turtle when he's hitting the wall right there? He's 40 by 40, and it's relative to his center, so you have to it's whatever this line is. If he ever exceeds to the left that line or hits it, that means he's grazing the wall. And that's x equals negative 180. You see how that is half of his length there? Half of his width. That's what we want to check for. So we're hitting the left wall if we're ever equal to negative 180, or x coordinate is ever equal to 180, negative 180, or like it tried to go farther than that outside each frame. So if it ever went farther than that, bring it back in as well. So we're definitely outside if we're negative 180 or smaller. All right. So if it's less than or equal to negative 180, we hit the left wall. Does that make sense? So that's the exact number now. Same is true for the right wall. This is going to be like it's x equals 200 over here, but we're talking about the middle of the turtle. So it's when the x is equal to positive 180 or any bigger than that, the x coordinate. That means we hit the right wall. All right. I hope that makes sense. And then the top and the bottom wall, it's all as you would expect. We actually did that for the ball. It's the same as the ball bouncing. So like, when are we just grazing the top wall? It's when our y is equal to positive 180 or it's any bigger than that. All right. And then the bottom wall one last time. That is, we're grazing this bottom wall if our y coordinate is, this is the line y equals negative 180. If we're that or any smaller than that, we're either grazing the wall or we're outside of it. Okay? So that's going to be the goal. So let's add some if statements to notice all of that. We have this here for the top and the bottom walls, which is nice. Let's see here. So I'm going to uncomment this region now, bring it back. So if we hit a wall, bounce off. Dun, dun, dun. So that's all these things. And this is like the first two. This is like if we hit the bottom wall, it's like this. negative 200 plus the width over 2, that is negative 180. So if we ever do that, we hit the bottom wall or we try to exceed it, bring the turtle back in, and then change the offset. We don't have that variable anymore. So it's like, is it the y or the x that we modify now? So we have to figure out how we bounce. All right. So now we know when we hit the wall, and then we have to figure out how to bounce. And we'll actually put this into a function. It'll make it a bit cleaner. So let's try and figure out what happens when we bounce off the wall. What should happen to our direction? The direction needs to change. Like if we're coming that way, we need to bounce off that way. And what does that mean to our direction offsets? How do those numbers change? So if this is us, and we notice we just hit the wall over here, for example, if we came in the wall from this direction, like our direction is this way right now, boop, we want to bounce off in what way? It's like if we're going in this way, we want to bounce off that way. Does that make sense? Like that's how it should look. What does that look like? Like what is that? There's a 90-degree angle somewhere. It's like we're coming in that way. And this was our x offset and y offset. It's like a little bit negative, a little bit positive, x offset, y offset. We want to bounce off. If we were coming in this way, we want to bounce off that way. So our direction, if I try to draw it accurately, it should go that way. Does that make sense? That's what our new direction should be. There should be like a right angle between these. And it's very similar, right? It's very similar to the other one. It's just like a little bit mirrored. So what does that mean? It means that we can reuse our offsets. Whatever this x offset was, it was going left. It was moving us a little to the left. That's why we hit the left wall. So this one has the same length offset. It's just in the other direction. Instead of going left and going up to move diagonally that way, we want to go right and up. That's how we bounce off. Does that make sense? How you split it up into those two different pieces. So take whatever your x offset was over here that you're moving left, negate that. That's your new offset for your x. You're going right now rather than left from before, but it's the same size amount of movement, just in the opposite direction. And then we're also still moving up. We can still go up. We didn't hit a top or bottom wall. So the y offset, whatever that was, is the same. So still move up by that same amount like we were, but instead of moving left and up, move right and up. Okay? Does that idea of bouncing make sense to us? I think we talked about it a little last time, but now we're getting into the nitty-gritty. And that's going to be the idea. If you hit a left or right wall, it's the x offset that changes. So like if we were coming into this wall, for example, this way, like we were going a little bit right and a little bit up, we want to bounce off this way, right? Which is the same triangle. It's just, all right, go left and up now instead of right and up. See that? It's the same offset, just a different sign to it. And then the bottom and top walls are exactly the same. It's just for the other offset. So like if we're coming into this bottom wall, that means we're coming downwards, like this was our direction. We want to bounce off that way, right? And so if our original direction was a little bit down, a little bit left, or yeah, down and a little bit right, sorry, then our new direction should be still go right, but go up now. You see that? That's the same amount, just in the other direction. So negate it. Whatever it was, negate the x offset if you're hitting a sidewall, negate the y offset if you're hitting a top or bottom wall. Okay, any questions about that? It's a little weird, but that's going to give us our bouncing movement. So let's package this into a function. It'll be a bit cleaner that way, I think. Let's make a bounce if hit wall function. We'll just steal all this and move it there. It's like, all right, then the draw frame function looks really nice, right? If we hit a wall bounce off, we'll just, all right, call the bounce if hit wall function, and that will just deal with that. Isn't that nicer and easier to think about in our minds? Let's do that. Let's go and program that function now. Def bounce if hit wall. We got to figure out what needs to happen. We're going to keep the stuff from before, of course. We're going to change it up a little bit, though. Let's see. So bounce if hit wall. So this is for the top and the bottom wall. We're mostly there, right? Now we know what to change. If we hit a top or a bottom wall, that means it's our y offset that needs to be negated for our direction. We still want to keep going the same x offset. That's fine. But if we were going downwards, we're going upwards now. That's the idea, right? So it's our y offset. That's what we're going to do. So change the y offset. So we move upwards now. Okay? So turtle y offset equals whatever it was negated. So if it was going down, if it was negative, make it go up. Make it positive now. Okay? That's how we're going to do that. And so this was also for the top wall. If we were going up a little bit and we hit the top wall, that means we need to move down now. But move in the same direction for x, that's fine. X didn't get us into trouble, okay? So that's how that works. Just change the sign. This was guaranteed to be positive if we hit the top wall. We're going to make it negative now, okay? So does that make sense? How I'm going to do that? So that was for the top and the bottom wall. I'm going to do it for the left and the right now. We're going to notice, like, hey, did we exceed the bounds a little bit? If so, bring ourselves back inside and make it work. So let's see here. It might be easier just like to hard code this stuff because it is like we know it's negative 180, positive 180, all that fun stuff. So like if the turtle ever was less than or equal to negative 180, make it exactly negative 180 and like bounce off. Bring it back inside. And this was exactly positive 180. Positive 180. That might be easier to just read later. But that was the top and the bottom walls. And all right. Let's do the left and the right walls. So how do we know we hit a left wall or right wall? It's when our x-coordinate this time is less than or equal to negative 180 or greater than or equal to positive 180. All right, so I can copy most of this. Boop. So if the turtle's x was less than or equal to negative 180, that means we were over here somewhere and we hit the left wall. All right, less than or equal to negative 180, we either hit the left wall when that happens, or if it's like legitimately less than, or we're trying to go outside of it, or we're trying to go past it, let's say. And so let's move the turtle back inside in the x location, move it back to exactly negative 180 if it was any less than that, and then it's the like this was the y offset again. Now it's the x offset that we changed because we were moving. Oops. We're moving a little bit, like, the reason we hit this wall is because we were moving left and up, for example. Now we want to move right and up. So keep the same y offset, the x offset gets negated, okay? So change the x offset so that we move to the right now, I guess. So that's for the x. And then one more for the left wall. That was for the left wall, for the x. And then one more for the x on the right wall. We know we hit the right wall if our x is greater than or equal to 180. Boop. If our x is greater than or equal to positive 180, that means we either hit the right wall or we're trying to go past it. So move the turtle right back and just grazing that wall again, make it exactly 180, put him on the edge, and then again change the x offset so we're moving to the left now. We hit the right wall. So that was this drawing. It's like, all right, we're coming in a little too hot. We're going to the left and up. Then we should move out. We should bounce out to the right and up. So take whatever our x offset was, go in the same amount, but the other way. So negate it. Okay? It's going to be a negative x offset because we want to move to the left now. All right? Any questions about any of that? That's pretty much the setup. They kind of seem self-explanatory enough. And there's a lot of code though. I'll give you that. And because I'm changing these variables, turtle x and turtle x offset and turtle y offset, those are global variables, right? They're defined out here, and I'm changing them inside of a function. I have to tell Python about that. Just be like, hey, I'm messing with these, and you should let me. Otherwise, it'll think it's a local variable, if you remember that. So that's kind of the idea there. And actually, you might remember me teaching you like ifs and elifs, right? This is just a bunch of separate ifs, and there's actually a reason for that. Because what if, right? What if this turtle, like, we did get the thing that was from the office, and we really did hit the corner. What does it mean to hit the corner? That means, like, we hit the right wall and the top wall at the same time, yeah? And so we should bounce off both of them at the same time. And so we have to be able to both notice that we hit, like, the top wall and the right wall separately. You see that? Because if it was an elif, we would never notice both at the same time. Does that make sense? And so we want to be able to notice both, so we'll separate the ifs like this. It can't be you'll never hit the left or the right wall at the same time, or the top and the bottom wall at the same time. So this could be an if elif, and this could be another if elif, but it can't be just one long chain of them. We need the ability to hit both walls at once and have both of those pieces of code fire. Because if we were going this way, up and to the right, we want to go down and to the left. That's negating each of the two offsets this time, having both of those pieces of code run. So that we don't have to change anything. It's all as we were doing it. It's just by separating this, we get corner bounces for free. So if you let our program run long enough, you'll notice that. Okay. I hope that makes at least a little bit of sense. But yeah, I think that's what I wanted to say. So yeah, every frame now, like we took so much care to do all this, right? We set up our X and Y offsets for diagonal movement, potentially. And then we normalize that so that we're always moving the same amount each frame. And then like our draw frame is pretty clean looking now. It's just like, all right, move relative to our offsets. Maybe that took us to a wall or outside of a wall, bounce off if we did. And then like that's going to change X and Y eventually. This is the good value now. We've messed with them enough. Go exactly to there, and that's going to make the animation happen. This will actually change where the turtle really is on the screen. Okay? So draw frame hopefully makes a lot of sense. The devil is in the details, though, of course. And the bounce of hit wall, there's a lot going on there. It's like we have to notice, like, did we hit the left wall? If so, how do we bounce off? How do we change our direction so that we bounce off in the correct looking way? How do we change our direction to bounce off the left wall, the right wall, top wall, bottom wall? We all need to be in there somewhere. Okay? But together, it seems to be a bit complicated, but it will work and it will be happy. So are there any questions about this code before I run it, and we'll see if anything blows up? Because we have all the pieces in place now. Drum roll, please, I guess. Here we go. Ooh, that's a bad direction. It's just a little bit too much up, exactly. But look at how clean that was. It was beautiful. So it's bouncing off the top and the bottom walls, and it's going to be forever to hit the left and the right. So let's pick a new random direction. But look at how gorgeous this is. We got another kind of useless X offset. Sorry, but eventually we're going to hit the sidewall. So here's us hitting the top and the bottom walls. It was too big, trying to get bigger than 180, trying to get smaller than 180. And there it grazed that left wall, and it hit one of these if statements. It's like, all right, it's trying to go outside. Let's move the direction vector to the right now. Sorry, I said the word vector, and we have not learned that word before. We move the direction offset to the right. And so now it's going to hit the left wall, slowly but surely. And it'll bounce off. It'll run our code that notices that it hit the left wall, and it's going to, all right, change the X offset to move in the other direction. Isn't that fun? And of course, it's a different thing each time, so maybe we'll get more diagonal movement if we rerun it. Nice, that was really close to a corner. This is moving a bit nicer, I would say. Lots of left wall. Ooh, that's close to, that might hit the corner, guys. Oh, man, so close. But this is very satisfying. It's a good program to study, and hopefully it makes at least a little bit of sense right now. Are there any questions about this code and how we changed our up and down bouncing to get left and right bouncing? Just, we considered a new axis, really, and that did it. All right. Before I change topics, let's remember how to like make it faster, right? If we want to make it faster, we change the offsets amounts. Like if it was moving, if X offset was 1 and Y offset was 1, it's going to move at a certain speed. If we double that, it's going to move at twice the speed, right? It's going 2 at each time. So if I just take this X offset and Y offset, and like if I change them a little bit, if I say whatever they were, like if I multiplied this by like 2 or something, it'll move at twice the speed. It'll move by 2 each time. The hypotenuse's length will be 2 now. Now it's 2 if I do that. Does that make sense? I'm multiplying it like that. So if I make that change, then it's going to move a bit faster. And maybe that's what we like. I don't know. But that's the idea. And like if you could like make it go crazy. Make the hypotenuse length 5, so it's going to move 5 units in the turtle world each time. And so that corresponds to speed, because we move by that amount. That's a little scary looking, every frame. Okay? So that's the goal, that's the idea. The hypotenuse length was 5 when I did that. So let's put it back to 1, as we had it before. But yeah, that's one thing you can play around with, and I encourage you to. So yeah, any last questions about this example before I switch gears to one other different example? definitely study this code. It's a fun little thing, I think. So hopefully you're getting the feeling that I have a goal in mind for these programming lectures in Python. It will be even more apparent with this next example. I want to be able to move something with the keyboard. I want to be able to move a rectangle, right? So if that doesn't give it away, that nothing will. So our goal is eventually to make the Pong game in Python. So we just got a ball right now, bouncing around. Now we need to paddle, all right? So let's learn how to do that. So if we want to make Pong, what do we need, right? We want a paddle, and we can make the turtle a paddle. That's fine. The turtle was a square because we stretched him in the same by the same amount in each axis. But if we stretch the turtle in the up and down direction more than the left and right direction, he will be a paddle. Like, this is kind of what we want. Like, we want a paddle over here somewhere. And so we can use the turtle to be a paddle as well. We'll just have to stretch him a little bit. Stretch him in the y direction more than the x directions. Like, stretch that way. Stretch just a little bit that way. Okay? So that's how that's going to work. And you can do that. That's turtle dot whatever. Turtle dot turtle size. See how it had two options? One for the x stretching and one for the y stretching. So that they could be different. It's a square when they're the same, of course. But it could be different. So let's get that started. And that'll be fun. Dun, dun, dun. So do I want to? I guess I do. Let's go for it. We got time. So I'll make a new file, and I'll copy and paste a lot of this in. We're going to try and get like this picture on the screen first. So new file. I'll call this paddle.py. So I don't need this right now. And then, oh gosh, I don't want, like, we're not doing animation. No more draw frame. No more bouncing off walls. Oops. None of that. We do kind of need an X and a Y, though. It's not the turtle anymore. It's like the paddle. So we'll deal with that. But let's try and get this picture drawn. Okay. So let's do that. Dun, dun, dun. I guess I need that eventually. But let's keep a lot of this stuff. The shape is a square, the fill color is purple, and let's do this amount of stretching. Apparently, if you stretch the turtle by 1.5 in the x direction, his original length is, what is it? The original length is 10, maybe? I think? No, 20. The original length of the turtle is 20 by 20 if he's a square. And so if we stretch him by 1.5 in the x direction, that'll make him 30 with his width. And if we stretch him by 6 in the y direction, that's apparently a good amount. That will make it 120 in the height. So that's the kind of paddle. That was apparently a good amount that I noticed last time. So let's do that kind of stretching. So stretch by, Mr. Turtle, please. We'll do it by 1.5 in the x direction and 6 in the y direction. Let's do that. What else do I want? So draw the bounding square. Make the turtle the paddle this time. Paddle. And so shape is square. Fill color can be whatever we want again. And the turtle size is that, and like the width doesn't really make sense anymore. So let's get rid of all that. And then, do we want to give him like a starting place? So originally we had like X and Y for the turtle. And we went there. Let's say that it's the, I don't know. Let's call it paddle X and paddle Y this time. Again, it can be random, but we kind of want to put it on the left eventually. We'll deal with that in just a second. And then, like, pick the turtle up and have him go there. The turtle's now a paddle, and that's the idea. So that should more or less do a lot of what we want. But he's kind of in a weird spot right now. Let's see, did we... Oh, sorry. Turtle got .go to, it's paddle X now, and paddle Y. That's a bit better. So yeah, it's just like a random spot, but that looks like a paddle. Let's just try to get it on the left now. Let's make that happen. Apparently, a good spot for the paddle is like over to the left. So let's set the x coordinate. Let's hard code the x coordinate to be somewhere over here. And then the y coordinate, maybe we can just start that off at like 0. The y coordinate could start off at 0, right in the middle. Something like that. I think that would work. So let's hard code all that when we start this. So like let's set the paddle y to be 0, center of the screen, And then the paddle X, let's make that like closer to the left side. It's like, because this is like, what? Over to the left is negative 200. A little bit less than that, like negative 175 or something. Apparently negative 170 is what I did last semester, and that looked good. So if I start off like that, it'll always start there, this exact spot now, negative 170 for its center. And that is a good place for the paddle, I think. So that's a good spot. All right, so does that make enough sense how I got that to be here? Just changing the stretching on the turtle after he gets made a square does this. That's the first thing. And then there is a way to have the turtle listen to the keyboard, listen to us pressing keys on the keyboard. It's called .onKeyPress. There's a function in the turtle library called .onKeyPress. And so there's some documentation about that, but it takes two things, two arguments. It takes a function to run when that key gets pressed, and then it also takes a string that you want to represent the key. So like you'd be like .onKeyPress, run this function f please when the up arrow gets pressed. You pass along as a string like that. Okay. That's kind of cool. Functions, we'll take another function as arguments, which kind of makes sense. Why not? So we're going to hook into the up arrow key press and the down arrow key press. We're going to make a function that gets called every time we press those. All right? I hope that makes sense. So we're going to use that every time we press a key, what we want to have happen. So we'll set those up down here. So it'll be like turtle.onKeyPress. Like when the up arrow gets pressed, we want to let's make a function called go up, and we'll pass along the up arrow string. It's like, all right, when the up arrow key gets pressed, it's going to call this function for us. When the down arrow key gets pressed, it's going to call this other function for us. Let's call it go down. That's how you tell the turtle about it. So it's just you say up and down, that corresponds to the key, and then these will be the names of the functions you want called when that key gets pressed. All right? So this is set up functions to run every time the up/down keys are pressed. That's the idea. And so let's make a go up function and go down function. So every time, like def go up, what does it mean to move the paddle upwards? So he's got a location, right? He's got a paddle X and a paddle Y. To move up, it just means like change the Y by a positive number. Yeah? Shove the paddle upwards. Change the Y coordinate of the paddle by a positive number. So just like paddle Y equals whatever it was, plus like 10 or something. I don't know. So that's the goal, and then go to there. Go to that new coordinate with the new Y. And because I'm changing Y and Y was a global variable, I have to say that global paddle Y. So I can change it like that. Let's go up, and then go down is exactly as you would expect. It's like, all right, go down, mess with the paddle. If I press the down arrow, I want the paddle to move downwards, so whatever its Y coordinate is, make it smaller. Do like minus 10. And then go there to actually move the paddle. All right, so this is us setting up the functions. You have to tell the turtle one last time to say, all right, I'm ready, I've set everything up. You say turtle.listen to have it start, like, put its ear to the keyboard, I guess, and start listening for the keys to be pressed. But this is all the work we got to do. Make two functions, one for each key press, and they'll get called when those exact keys get pressed. And then tell the turtle we're ready, start listening for those keys, and then here's what happens. So here I am pressing the up arrow, and it's running that function every time I tap the up arrow. Cool. Every time I tap the down arrow, it's calling the go down function. And you can hold it in. Whee! Any questions about that? Does that make sense? Not horrible. Just I'm changing the location of the turtle every time it's running that function. The go up or the go down function. That's pretty cool. We're almost there, right? We're almost making poem. The last real piece of the puzzle is I can exceed the bounds right now. I'm just like minus 10, minus 10, minus 10. Or plus 10, plus 10, plus 10. I'm not worrying about hitting the walls. That's the last thing. If I press up, if I'm sitting right here and if I press up, I want it to not move the paddle. Because that's outside the bounds, okay? So that's what we need to watch out for. So that's why I took care to tell you how wide and how tall this thing is. Because we want to stop the paddle right when it gets to here, right? Once it gets to the top and it just grazes it, never get past it. So this is the line, right? Y equals 200. But this is the center of the paddle. It has touched the top or exceeded the top when it is its center is right here, right? And so that's 200 minus half the width of this paddle, which is apparently 120, so this is 60. So minus 60 for there, and that'll take us to y equals positive 140. So if our y is already 140, don't let it get any bigger, because that would go outside the bounds of the window. Does that make sense? That's the goal there. So we're just going to add, we'll add an if statement for that to the go up. And then we'll do something similar for the go down. So if we want to go up, like, all right, yeah, try to change the paddle's y, but make sure we don't go past the top. That might have been too far. If paddle y, let's go back to here. If the paddle's y is now a bit bigger than it should be, if paddle y is equal to positive 140, or if it's any bigger than that, like we try to go even farther, who knows how, then make sure nothing happens, right? Set the paddle y to be exactly 140 if it wasn't already, because maybe we went outside. So that's going to make sure it doesn't get any bigger. Like we try to make it 150 or something, it's like, no, bring it back. Bring it back to 140. Don't let it get any bigger than that. Does that make sense? That's going to be the goal there. And that'll force it. That'll force it to stay at most 140 when I press up. So now I'm pressing up right now. I'm holding up. And it's like, nope. No thank you. It's not letting anything happen. I can press down, and I still have that problem. So let's deal with the downward direction now. That's going to be what? It's symmetric, right? So it's like negative 140 if it's down here. Don't let it get any smaller than that. It's symmetric. So if we're ever going down, don't let us get too small. Don't let us get past the bottom. So that's if we're ever equal to negative 140, or you're trying to get any smaller than that. So just set it to exactly negative 140, because that's grazing the bottom, just like positive 140 was grazing the top. All right? So that's the goal for go up and go down there. And there we are. So if I press up, hold it in, I'm pressing it hard, it's not working. It's not going any farther up. Those if statements are blocking me. Perfect. And then same for down. I'm pressing down, but it's not going any farther down. It's staying within the bounds because we checked them. It tries to make it 150, but it stays 140 because of that if statement. It tries to make it negative 150, right, because we're moving by 10 each time. It's making sure that if statement's firing. It's like, nope, you're going to stay negative 140 and you're going to like it. Okay? So that is key presses in Turtle Land. Any questions about any of that? Because now we kind of just have to combine this and then the ball bouncing, and we have Palm, which is exciting. That'll be a job for a future lecture. So if we are happy with this, of course I'll give you all this code. Please study it. It's good to study a lot of examples of stuff. I also, before we go, want to talk about your final exam, because we're in week 15, right? There are 17 weeks of classes. This week 17 is the last week of classes. Week 18 is the final exam week, right? So I'm going to publish the final info page. Don't pay attention to the date on the final yet. I'm not ready for that. Only look at the info page, so now you should have access to it. So because we have a scheduled class time, there is a time for our final. And so this is what was on the syllabus, but here I am recreating it. So apparently we have been scheduled to take our final at class time on Wednesday, on the Wednesday of finals week. So that's December 6th. Because it's finals week, you don't show up on Monday to this class of finals week. Just the 6th is our final exam. Nothing on Monday. That's for other classes. Okay? That's when it's going to be. And then here are the topics. You should expect it to be pretty similar to your to your midterm. But I'm going to have Python questions this time. I promise to ask you Python questions, so get ready. Practice your programming assignments. Go and look over those. So I'm going to ask you to write another essay, a little short essay to get up to our word limit that we're required to have this semester. And then I'll ask you a bunch of Python questions. All right, so it's critical thinking, logical questions, but in code this time. So prepare to write code, and you're like going to paste it into Canvas, because this will be on Canvas again. Okay, so make sure like you're comfortable writing code in idle, and like copying and pasting it, or wherever you write your Python code. So just get ready for that by practicing. And yeah, to prepare, just like I'm going to take my questions from like programming assignments and every example program that I wrote in class. So if you look over all of those, you'll be pretty safe, I think. That's how I'm going to come up with the questions. And like, for example, I'll ask you to like draw something with the turtle library. You can definitely expect to see that on the final in at least one question. right? Just like the midterm, I'll have the essay count for a lot. But I think that is all that I wanted to say about that. Yeah, then the rest is coding questions in Python. Some will be like you write the whole thing, and some will be you fill in the blanks, stuff like that. And that's how I plan to do it. And just like last time, the test is open book and open notes. So you can look at all the slides, look at all the sample code if you want. You just can't talk to a human other than me. But this is when our final is going to be. Every final is meant to be like a 1 hour and 50-minute chunk, so it's a little bit longer than class time. So have this amount of time to take the final in this room on December 6th. Okay? Any questions about any of that? I think that's all the pertinent information. So just let me know if you have any new questions that you think of. But I think that's all that I wanted to say. So yeah, our final, week 18, the Wednesday. There's nothing on that Monday. That's for other classes. Might have something scheduled then. And yeah, I think that's everything that I wanted to talk about today.